Hello everyone, I welcome you all to this awesome video of structural analysis. Uh, Here I will be dealing with this question, the specific question which I have drawn over here. This is Hibbeler 122, chapter number 1, question number 22. And I specifically chose this particular question because this is a little tricky, not very difficult, but a little tricky, and I uh, also wanted to go through steps of solving the usual structural analysis problem. And most of the time whenever you see a mechanical engineering problem, it will always be practical. It will always be a practical problem, and therefore you can always think it in action, and then you can always come with a logical approximate result. And therefore I always try not to solve a question using a pre-specified step, but I try to build the solution step by step on my own according to the logic, and that always works for me. But in structural analysis I've always seen that the predefined steps that usually the textbooks lay down, they work really well, and they actually have a great value, and I advise and recommend everyone to go through those steps and make it a habit to solve each and every problem according to those steps, because it always helps you to solve at least 99% of these problems, keeping in mind certain assumptions. So there are certain assumptions that you must always keep in mind. The first one, of course, is whenever you have a reaction force which is unknown, even though if you know the direction of these reaction forces, never ever apply the signs, because the sign will generate on itself in the equations. For example, this particular force over here is a reaction force, and I know that since the weight is acting downwards, this reaction has to occur in the upward direction, so it would be something like that. I know this, but when I write down the equation equating the forces in the y and x direction, never ever write down the signs. That's the first, not just the assumption, but probably you call it postulates or something like that. I hope I make myself clear. So never ever put signs. That's the first assumption. What's the assumption is that whenever you are solving such question, always consider the externally applied forces. It has troubled me for so long when I was trying to solve the questions in which you would have a bar, something like this, and then there would be another bar, and then there will be a rope which would be going over it. Yeah, something like this, and there will be a pulley over here, of course, to support the rope. While solving these kind of problem, there would be a reaction which would be acting in this direction, but I was always getting confused, because when you pull a rope in this direction, there will always be a force acting downwards, right? The force would be acting downwards, and then there will be, and then when you apply the fx is equal to the summation f of x is equal to 0. When you apply this particular formula, I always tend to include these forces also, but these are internal forces generated because of these forces. So it's not a new force. It is not a new force. It is an internal force. The only external force acting is, maybe in the question it would have been given that there's a weight acting downwards, so that's the external force. The other external force is the reaction which is supporting the whole structure, which is this. And then there are a number of internal forces acting here. So if you would have, usually you might have seen a lot of such kind of questions, and I hope that I'm assuming that you know how to solve these questions. In these kind of questions, what we did is we would cut the bar at that position, and then we analyze only this half of the question, right? In this situation you have to include the internal forces also, but not when you are trying to calculate the moment that is being generated at these points. So that's the second assumption. The first assumption, never put the signs. The second assumption, always consider just the external forces, not the internal forces. There could be other assumptions also, but as of now I would just go through these, and I'll let you know if I come across more. So let's go ahead and try to solve this particular question, which is a little tricky, but I will give you a few steps to solve these questions, and whenever you follow those steps, I guarantee you'll be able to solve 90%, 99% of these structural analysis questions, keeping in mind those postulates, those two postulates that I put forward. So you might have seen a number of structural analysis questions which are simple and are very common, and these are simple beams, loaded beams. So usually there would be a beam supported by this wall, and this is a cantilever beam, as you can see, and then there would be certain questions which would have a uniformly varying load in these directions. Okay, so and you would be asked to find the internal loadings at any point, maybe this or maybe that. So the way we went about solving these questions is, the first step to solve is to replace all these supports and joints with reaction forces, so that we call as a free body diagram. So we always draw the free body diagram. So we draw a free body diagram and we put the reactions. So what are the reactions? Usually people confuse with the term reaction. Reaction is nothing but a replacement for this wall. So what if this beam was not attached to a wall, but it still behaved in a way as if it is attached to a wall? So for it to behave in a way that it is actually attached to a wall, without any wall at this position, we need to have certain forces which are taking care of it. So imagine you're holding a pen or maybe a bar. In order for this bar not to go down, we need to have force in this direction, which is supporting it in the upward direction, and it is also not so that it also doesn't translate in this or in the x direction. There must also be a force that is holding it in this direction, like that. Okay, so it is not translating anywhere. This edge is not going up, or it's not going in the xy direction, and therefore the beam stays as it is. But there's still a possibility of the beam revolving at this point, right? It can rotate, not revolve, rotate. So in order to stop the beam from rotating, we also apply a moment which will hold it. It's like pushing it from down, like that, at this position. So it will be in this direction. I'm sorry, it will not be in this direction. Right? So let me clearly draw it so that it stays as it is. So these are the reaction forces. So in free body diagram, we always try to draw the reaction forces and replace all these supports, and then we draw a uniformly varying load. Okay, then what's the next step? We analyze what is the point that we need to calculate the internal loads at. So if you're calculating this point, taking this point as to calculate the internal loading, you usually make a section at this point, right? Just make a section there, and you analyze either of the two sections in order to find the internal loadings that are acting at that point. What would be the better choice in this situation? See, these are the reaction forces which we do not know, right? When we slice it off from here, there will be other reaction forces at these junction, at this junction, and then there will be two sets of unknown reactions which will be difficult to solve. But when we know these uniformly varying load, we can replace the whole uniformly varying load by one single force. Force is in black, so we can replace that in one single force, and we know these forces because it would be given in the question. And then there will be only one set of unknown reactions acting at this junction, which we can calculate. So there is just one unknown, and there is one known factor. So this section would be easier to focus our attention to rather than this one. So yeah, and then we equate the when we have this particular section now, we can equate we'll have these reaction forces acting here, and then we can use the equations. Yeah. So this is the normal step by which we used to solve it, and this is exactly the step by which we'll solve this big question, which looks a little complicated, but we definitely need to find some relevance to this question. And since this is the exact step by which we will be solving it, we will go through it right now. We'll go ahead and make the free body diagram of this question. So for that, we'll just remove all these things. I hope you remember these steps, but I'll definitely go through them as I solve. Let's replace this with this free body diagram. So you have to see how many portions, how many things are there in this question which have to be taken into consideration. So there are two beams. So this is the first beam, this is the second beam, and then this is the third beam. There are three different portions, and we have to analyze. And these are just reaction forces, right? This is a reaction force, a hydraulic pump, which is pushing it up. Not pump, hydraulic piston, which is pushing it up so that it can support the 600 kg mass, which is pulling it down. Apart from that, so basically we'll just go through our first step, which is to make a free body diagram. I'll make it a bit larger with more gaps.